Okay, so this is a hyperbolic grazing orbit of the Earth. Initially, we are 1.87 degrees displaced from the Earth's center, and we're at a velocity of 2 kilometers per second. And that will place us on a hyperbolic grazing orbit. First, we're going to point the nose of the ship at the center of the Earth, which you will see in a second. Okay, so now we're going to increase the time speed to 100 seconds per second to approach the Earth more rapidly from our initial altitude of 71,000 kilometers. I calculated the 1.87 degree yaw offset from the Earth's center and also the 2 kilometers per second approach speed to graze the Earth at an altitude of about 1,114 miles. You'll see as we approach the Earth that initially we'll be over the United States. In just a little bit you will see there, I believe you can now see the lights on in the United States. We're still approaching at 100 seconds per second. I believe we're going to slow down to 10 seconds per second in a little bit. So let's wait for that to happen. We're still approaching the United States. We're still at 100 seconds per second. This is a highly elliptical orbit. I believe the eccentricity is 0.95. And as I said, we came in from an altitude of 71,000 miles down to a mere 1,114 miles at periapsis, which is still, we have ways to go to do that. Okay, now we're at 10 seconds per second. So the simulation has slowed down. Eventually we're going to approach daylight over the Asian subcontinent, South Asian subcontinent, and we'll actually be over the country of India as we reach periapsis of 1,114 miles altitude. But as you can see, we have yet to leave the North American continent. We are about 5 minutes and 20 seconds into this video, which lasts 18 minutes. And by the time we've reached 18 minutes, we will be above the South Pole and actually departing from Earth toward our apoapsis of the orbit. This is a 40-degree field of view that we're in, which is about our field of vision. So this is how you would actually see the Earth through the viewport of your ship. This is the XR5 Ravenstar orbiter ship. And of course this is Orbiter 2010. Now you can see the Earth is now beginning to occupy the entire viewport of the ship, and eventually all we'll see is land beneath us. It's going to get light fairly soon. Okay, now you'll notice the map MFD appeared on the left side of the control panel, and if you notice there's a plus mark on the right side of the map, and it's moving toward the left. That plus mark, the intersection of those two lines to form the plus, is where our ship is currently located, and you can see that it's moving along the green orbital line. We've just entered East Asia and are heading west, and it's just beginning to get light. You can see the ground beneath us moving. I believe at the moment we're at 1 second per second. I just slowed it down temporarily. Okay, now the light is definitely coming into view. We are over Central Asia. And now we're moving at 10 seconds per second again. And back to 1 second per second. I slowed it down because I want you to see how the altitude decreases to 1,114 miles at periapsis, and also if you notice on the attitude MFD screen, the vertical velocity is increasing while the fore and aft velocity is heading towards zero. That of course means that we will be have total tangential velocity when we reach periapsis. And at that point we will not be moving either toward or away from Earth for just a moment. And after periapsis we will be of course heading away from Earth. Now this is real time, 1 second per second, so this is exactly what you would see in the same time frame as you're currently in if you were looking through the ship's viewport. I believe we're over the country of India now. Alright, so now we have, I believe we have, yes, we're now beyond periapsis. We're heading toward the sea. You can see the blue water right before the little arrow, which is, the tip of the arrow is straight down toward the center of the Earth from our vantage point. Okay, so now we are over the water. And the next thing, I'm going to accelerate to 10 seconds per second. The next thing, body of land that you'll see beneath us will be Madagascar, which is just off the African coastline. You can see the plus mark on the map approaching the African continent. Now right in front of us is Madagascar, which you'll see in total in a second here. Alright, now I've slowed it down to 1 second per second real time so that you can see the ship actually cross the Madagascar coastline. And now we're back up to 10 seconds per second. And now you can see this South African coastline. Africa is upside down from the way you usually see it on a map. And there is the South Pole at the upper left corner of the view screen. And now we're beginning to see the entire globe of the Earth as we head higher to higher and higher altitudes. And now I've increased the time factor to 100 seconds per second. As Earth slowly fades in the distance and we approach the terminator, which is the line between light and dark. And there you have it, a hyperbolic grazing orbit. We came from a very high altitude where you saw the entire Earth all the way down to nearly touching the Earth, and then departed to go back to the original altitude.